the next point. We should ensure whatever we see is clear.
That means work is being done, we can see that it is in opposite direction.
Welcome, my students, to another time on the e-learning platform. I am your usual teacher on metalwork. My name remains Nathaniel James Yayok. And today, we are going to be discussing on a topic, screw threads, with the following outlines. Definition of screw threads, the uses and application of screw threads, types of screw threads, some thread terminologies, methods of cutting screw threads, stroke procedures. Under the procedures, we have the tap and dice method, and also the lathe machine method. We take a summary, and then finally, we take our assignment. Come with me as we go through the definition. Now, a screw thread should not be a new word to you as a metal student, because we have been using screw in our day-to-day life activities, especially in fastening component parts together. We use screw threads. Now, a screw thread is often shortened to a helical structure used to convert between rotational and linear movement or force. It could also be seen as a ridge wrapped around a cylinder or cone in the form of a helix. The International Standard Organization, ISO, have a metric screw indicates the outer diameter of the thread in millimeters. For example, we have the M6, M8, M10, M5, and the likes. Now, this M symbolizes the metric and is universal, acceptable anywhere. So it's standard. That is why the International Standard Organization make the screw with number M to show that it is standard. For instance, you can have an M-thread screw in Nigeria, taking it to America or the UK. That M6 or M10 is the same thread you find there. So you can use the M-thread anywhere. That is why it's standard. Now, screw threads are made smooth and rough. They are also made right-handed or left-handed thread. That is how screw threads are made, depending on the purpose of which they intend to serve. Now, let's go to some uses and applications of screw threads. Number one use of or application of screw thread is it converts rotary motion into linear motion. Rotary into linear. For example, the lead screw of a jack is one example of rotary motion that is converted to linear. You know, when we say rotary, something that is moving around, and then linear is moving on a straight line, either horizontally or vertically. So here, one uses or application of this screw is to make sure that this movement is obtained. The second application is it prevents linear motion without the corresponding rotation. Here we mean a thread cannot transmit motion unless it has a corresponding thread that match together to be able to move and give that movement. That is, we have what we call the male thread and the female thread. The two comes together, having the same pitch, the same diameter, they roll together to transmit this motion. Without the female or the male, motion cannot be transmitted. 3, it is used for fastening wood, metal, plastic, etc., using bolt and nut. Now, most of the component parts, the chair, on aircraft, motorcycle, and all that is around us, when you check, you see in one place or the other, there is a use of a screw, thread, a bolt and nut, or otherwise. So this is very, very important in fastening component parts together. Example of a screw thread, we have the bolt and nut, which is the basis of our lesson today. The bolt and nut is displayed. We have the bolt at my left, splitted. The bolt and nut are displayed on the board. The one at the left side is the nut, which carries internal female thread, while the one at my right is the male external thread, which is called the bolt. And from my immediate right, we have the assembled of these two components together, the bolt and the nut. Now we also have an example of the screw thread, where we have the jar lid. The jar lid is displayed, and it's also carried a thread on the cover and also on the jar, that when put together, just as the bolt and nut, you will have the thread being controlled by transmitting the motion to either tight the jar or loosen it. We have various types of bulb, light bulb, which carry screw. You agree with me? Even at home, we have such types of bulbs that we use to screw in to the lamp holder. Now, tying it on the lamp holder and losing it, this what permits this losing and tying is the screw that is in or on the light bulb and the lamp holder. Then we have the swivel chair. The swivel chair is a comfortable seat that you sit on and can rotate 360. What enables the swivel chair to rotate is the screw thread that is beneath the seat. A construction work is done, a male and a female thread is worked beneath the seat to give the chair a comfortable turning around or turning over or swivel. Now, let's see some of the types. Among all these screws that I've mentioned, they are made in form. Now, types of screw threads. Number 1, we have the unified screw thread. It's also displayed on the chart. And this unified screw thread is basically used for general purpose. We have the metric. The metric screw thread is also used for general purpose. We have the square screw thread. The square screw thread is an ideal thread for power transmission. It is used mainly for power transmission. In form, it's a little bit different from the general screw thread. Then we have the next one, which is Acme. The Acme is more stronger than the square. It's also used for transmitting motion on wheel and on a jack. Then we have the last one, which is the buttress. The buttress is designed to handle heavy forces in one direction. Heavy forces in one direction. Example of that can be found in truck jack. We know that a jack is made to carry vehicle up or to lift it up. Now we have the one that is meant for the truck because the truck are more heavier than the normal vehicle we have. So this buttress tread is mainly used on truck jack. Now there are so many terminologies that we need to know in trying to identify a screw thread. Number one, we have the pitch. The pitch. The pitch of a thread is the distance between two crests. The pitch is the distance between the two crests. We have what we call the angle, or the thread angle. Is the angle between the thread or the reach. Don't forget, I said a thread is a tool, or sorry, is a component that carries reach round the cylinder. So on the thread, we have the reach. So this reach, there is an angle between one crest to the other crest. That forms the angle, the thread angle. Then we have the crest. The crest of a thread is the top part of the groove that correspond with the major diameter. The next one is flank. The flank is the angle at which the helix rises to form a crest. And we have another one, which is the root. The root of the thread is the bottom of the groove between the two flanks. We have the depth of the thread. Every thread have a depth, a limit where you cut and stop. Now the depth of a thread is the distance between the crest and the root of the thread. We have what we call the major diameter, which is very, very important. Every thread have a major diameter, and the major diameter is an imaginary largest diameter of the thread which touches this crest. The last one is the minor diameter. And we say the minor diameter here is an imaginary smallest diameter that touches the root. Now looking at the screen, we have a display of the screw thread showing all the parts that I have mentioned. We have the pitch, we have the thread angle, we have the depth of the thread, the minor diameter, the major diameter, the crest, the root, and the helix angle. All of these are the terminologies that we need to be familiar with anytime we are talking about a screw thread. Now, having said that, my students, we need to know how to cut or produce these threads on a simple workpiece. Now that takes us to the methods and tools that are used for cutting these threads. The method of cutting screw threads includes the following. A, center lathe machine method. B, bench work method. However, taps and dies are used for the bench method. Tap and dies are used for the bench method. Now, for the lathe machine, because we do not have a lathe machine here, but on the screen, you can see two different operations going on. By my left is an operation, and it's a threading operation on the lathe. By my right is also an operation that is being done on the lathe. But the one at the left my left is the internal threading operation on the lathe machine, while the one at the right is the external threading operation. That is, the female and the male threads can be cut on the lathe machine. How do we do that on the lathe? Now, the first procedure is hold the cylinder or shaft on the jaw chuck of the lathe machine. 2, reduce the shaft to the required major diameter. 3, hold the shaft between the lathe machine. And then 4, select the correct pitch stroke diameter that you are to produce. Because the lathe machine has a gear selector that enables you to select the gear that will give you the pitch and the diameter, exact diameter that you need to produce on the thread. So select the correct pitch gauge and suitable speed. We use low speed in producing threads. We don't use the high speed for the threading. Number 6, engage the automatic feed shaft to test run on the workpiece. Engage it to test run to see whether it is exactly what you want to cut. Then the next one is use the pitch gauge to check. And if it is correct, then take another cut anti-clockwise to produce right-handed thread. We are producing threads either left hand or right-handed. Now on the lathe machine you can do that. So when you are taking an anti-clockwise operation, you are producing a right-handed thread on the lathe. Now the next step is take a cut clockwise to produce left-handed thread. Number 9, repeat step 6 or 7 to obtain the final thread. Now on the bench, I said we have what we call the tap and dies, and it is used on the bench to produce or to cut the screw thread. Now, this set is the complete set that is used to produce internal female thread and external male thread. We use the tap. We use the tap to cut the internal female thread. And the tap comes in 3. We have the first tap, the second tap, and the plung tap or bottomy tap. These 3 taps will go straight into the hole that you have drilled to produce the thread. Now, having said that, let's see what are these taps and how we use the tap. The taps are the tools used for cutting internal female thread. They are made of high carbon steel or high speed steel. Tap comes in 3, like I said. The first tap or taper tap, the second tap, and the plung or bottomy tap. The tap consists of a groove called flute. Now, between the cutting edge are called flute. It has a groove in between the length of the tap, and this is called the flute, where is used to pass out waste material which is known as chippings, to escape, and also cutting oil into the work to reduce friction while cutting. Tap is used in conjunction with a tap wrench. Now, you cannot use a tap without what we call the tap wrench. This is the tap wrench. The tap is slotted using the square end of the tap wrench, and then you hold your tap this way. Now, ideally, after cutting the workpiece to the required size, drilling it to the required diameter, you take it to the vise, tie it there, and then hold the tap on the hole with the first tap. Then you start tapping. By the time you turn twice, then you relieve. Take an anti-clockwise cord to relieve the chips to come out. By the time you run the first tap, you insert the second tap, as well as the third tap to finish the hole or to finish the thread. We have the next one, which is used to cut the external male thread. External male thread. And we say we have the dies. The dies are either of high carbon steel or high speed steel, and are used for cutting external male thread. The die also comes in three parts: the half die, die nuts, and circular split. These are the three forms of dies that we use to cut external male thread. The dies also is used in conjunction with a die holder or a die stock. Now, this is a die stock, just like the tap wrench. Now, the dies is slotted. This is the die. It's slotted into the die holder and is held by a nut. And then you have your die inserted in the die holder. Now, the process of dyeing or making an external thread on the bench is the same as tapping to produce the internal female thread. Now, before we summarize, I would like us to see a typical screw, a screw thread that is used for fastening component parts together. We have the bolt and we have the nut. All of these parts are threaded. This one is threaded internally, while the bolt is threaded externally. Now, when you put them together, you have your motion being transmitted to hold or fasten component parts together. Now, like I said earlier on, we have the left-handed and the right-handed threading. Now, this part I'm holding, by the time you turn the knot clockwise, you are tying the component part together. That is a right-handed threading. When you are losing, you take it anti-clockwise. That tells you that this is a right-handed thread. Now, on the other side, if you are turning it clockwise, you are losing. While if you are taking it anti-clockwise, that is when you are tying the knot. So this shows us that we have a right-handed thread and a left-handed threading. It depends on what purpose you want to achieve. We also have the smooth thread and a rough thread. For instance, the external diameter of this thread is M10, and I have a knot of also M10. But because the thread being cut on the knot is a rough thread, while the one I'm holding by my left is a smooth thread, the bolt cannot go into the soft thread. That is the difference between a soft thread and a rough thread. Now, this is the pitch gauge. This is the gauge that we use to check to see whether we have the pitch exactly the one we want to produce. Because you may have the same diameter, maybe 10 diameter, but the pitch is different. The pitch are indicated here. 0.1, 0.2, like that. Thank you for listening. My student, we have come to the end of our lesson today with the topic threads and thread cutting. But before we go, I would like to leave you with the following assignment. Number 1A, what is a screw thread? What is a screw thread? 1B, mention 3 uses of screw threads. Mention 3 uses of screw threads. Number 2A, list 4 main types of screw threads and state their uses. Number 2A, list 4 main types of screw threads and state their uses. 2B, describe the following screw terminologies: root, crest, and pitch. Describe the following screw terminologies: root, crest, and pitch. Number 3, differentiate between tabs and die using sketches. Differentiate between tab and die using sketches. Thank you. In case of any other question or response, don't hesitate to reach me on my number 081 30 86 32 82. I repeat, 081 30 86 32 82. My name still remains Nathaniel James Yayok. Stay home, stay safe, keep learning till we meet.